And now we talk about the next topic, and there will be some questions covered. What are the advantages of the IoT edge computing technology? What it offers to the market, and what stands behind its growing popularity among businesses? Why edge computing may be a groundbreaking force in reducing latency, overcoming bandwidth requirements, and exploring the security implications of edge of computing. Denis Hukov, the head of the IoT unit at Yalantis, our second speaker, knows the answers to all of those questions. So Denis, please join us. The stage is yours.
Yeah, hello guys. One more Dennis is here. So let me share my screen and let's Mortal or Edge Combat begin. Here we are. I hope you can see my screen now. And let's go. So Victor already told you about my topic, so I'll jump directly into my agenda. So the agenda for today is edge computing as a technology and edge to cloud synergy. Actually, business impact of edge computing to your company or to your business, and future trends of edge computing, and of course, its stack or vendor selection for edge computing implementation. Let's go further. And for this slide, it's a small warm-up for you, actually. So what you can see on this slide, it's two planes, two flight jets, and they are kind of the same, but they are different. And the difference between them, I will give you a few seconds. 1, 2, 3, 4. So the main difference between them is the pilot view. As you can see here and here, so that's the previous version of the jet, and that's the newest version, like newest for the Second World War, actually. But here it's the view. And view gives what? View gives more information or more data. And what does it mean, more data about battlefield? It's about surveillance. So it allows to make vital decisions faster. So main point here is the speed of decisions has meaning. And let's start from terminology, because we need to clarify some terms, because there is a lot of confusion about edge computing. You will understand why I said about speed of decisions later, because it's definitely the core aspect of edge computing overall. And let's clarify some terms. There are a lot of discussions, and people seem to be talking about different things, speaking about edge and about edge computing. And it's actually essential to use clear language. So let's start from this point. And what is the edge? Edge actually is where the client endpoint device is located. And what's really far in the real world, the far is the cloud. The far is the data centers, yes? And overall, edge computing is a term that refers to smart computing resources situated near where data is used or created. So as one of well-known guys said, Leonard Lee, he says edge extends from the default location to anywhere and anything, but not the central cloud. Let's go further. And on this slide, I just want to show you a little bit trend of popularity of edge computing. Yes, and by 2028, majority of enterprises will be using edge computing according to the Linux Foundation. And in addition, Gartner predicts that by 2025, more than 70% of organizations, frankly speaking, I don't really believe in this statement. However, they predict like more than 70% of enterprise generated data will be processed outside a traditional centralized data centers or clouds. So we are speaking about edge and we are speaking about the cloud. Let's just try to compare both of them. What advantages and disadvantages each of these solutions have. And as the volume and velocity of data increases, so to that the inefficiency of streaming all of the information to a cloud or data center for processing. And edge data is often too big to move. Actually, that's really big. Let's assume just, I don't know, recordings of high quality video, and you should just send this information every second, and for 1 second, and it might be a few gigabytes of data, and that's a huge problem for cloud. And processing edge data at the edge allows us to generate value that simply was not possible even just a few years ago. Also, we are facing, you probably also like aware of that, we faced with the growing complexities of the public cloud. And that's a lot of innovation that's like AWS or Azure or Google gave to us, and a lot of new features, but it's sometimes too complicated and cumbersome, yes. And what sets edge computing apart from cloud computing is that the server is positioned outside of traditional hyperscale public cloud environments to corporate data centers. And the edge server is strategically located nearer to the primary site where this data created. So it gives us speed, as I said, speed of decisions, and reduce the latency. You probably can compare all of that. I don't want to stop in here for a while. Let's just move further. What's actually driving the shift back to edge computing as a trend? Why I said shift back? Because actually manufacturers have been deploying gateways and servers on their factories, on their facilities, on premises for a while. And so what's now driving to move back to the edge computing trend? And I prepare kind of reversed root cause analysis. Yes, it's about about benefits of edge computing. And there are 4 core benefits from my point of view. It's operational efficiency, it's about decision making, it's about security, and it's about costs. So from my point of view, businesses can't tolerate cloud-related delays anymore. Some of businesses, not all of them, obviously. And nowadays, companies heavily rely on getting quick, real-time information. Any processes needing fast data access must have computing right where the data is created and used. This becomes even more crucial when we are using AI or ML, machine learning. So because quick analysis and decision are crucial. The cloud has limitations when it comes to providing instant feedback. The edge offers companies more opportunity to keep the data within their own walls. For instance, in a lot of countries, like hospitals, they cannot upload the data to the cloud. So they have to have these edge servers on premises. And that's one of the points. As concerns of software supply chain lacks and security threats continue to grow, the edge removes the need to constantly move large amounts of data. It's also about the previous example. And edge computing allows a remote server or data center to act independently, regardless of outages or connectivity issues. Speaking about costs, it's also became a normal thing for now to pay a lot, like a few $1,000s per month with cloud services. Yes. So if a company has its own computing power, it can be more cost effective than handling it in the cloud. Of course, we should consider to take in mind like the price of maintenance of the system and operational expenses for specialists. However, it's still worth it for a lot of companies. Also, edge computing uses less internet capacity and network resources because devices don't have to constantly connect online for data transfer. This cuts down on the expenses associated with network costs, network usage. So edge computing eliminates the need to move data since it's processed right where it's generated, reducing the amount of bandwidth need to handle data. And actually, if managed correctly with processing at the source, edge data can drive vast new businesses opportunities and manage tasks that have until now been manually costly and even often unreliable. And where you can use it, yes, which spheres, which companies should do this edge computing? So as we discussed before, edge computing allows companies to extend their opportunities for data collection and analysis, service provision, security, decision-making, and improving overall business productivity. However, it's important to envision the potential benefits for your business when it gains a clear view right to the outer edges of its operations. So to do that, each business should answer the question, what improvements to your products or services could become possible when you will integrate edge computing? So sometimes you just don't need edge computing, that's fine. And there are a few examples like manufacturing. In case of any unexpected outage or issue, processing on the edge can save you much time and money by either predicting system malfunctions or notifying you in case any critical issue has occurred, or in case of bad quality of your product. It's better to define this bad quality on the line, not sending this bad quality product to your end users. That's obviously. Healthcare, it's also remote patient monitoring, diagnostic, robotic surgery, so it shouldn't be any latency in here. Immediate emergency response are life-saving examples of edge computing applications in the healthcare industry. Agriculture as well, so it's monitoring crop growth, soil characteristics, when you need to gain data and make decision like really fast. In retail, it's also useful. You can analyze shopper traffic flow within stores to determine where high margin products are based to be placed. It's also about security. You can check like if someone wants to steal something, yes, from your store, for instance. Smart cities, it's actually, that's the great example. It's a large distributed network of smart devices across large cities allows edge computing to reveal, like, to create magic. With edge computing, city authorities can maintain control of all over the city and immediately react in case of emergencies, or even take proactive measures in response to potentially hazard situations. It's also about managing traffic, I don't know, parking lots, public security, a lot of different things. Let's move next. So here you can see a few layers or types of edge computing. That's a little bit complicated. Let me to explain to you. You can see here, the bottom, it's micro edge, then thin edge, then thick edge, then cloud. And you can see it's latency decreasing, but distance increasing. So what is that? Micro edge describes the intelligent sensors devices that generates data. Micro edge devices are typically equipped with low-end processors due to constraints related to cost and power consumption. Thin edge. Thin edge describes the intelligent controllers, networking equipment, and computers that aggregate data from the sensors, devices generating data. Thin edge compute resources are typically equipped with middle tier processors, and sometimes they also include AI components. So there are three types of compute resources related to thin edge, and that's computers, network equipment, and controllers. Moving forward, thick edge. The thick edge describes compute resources typically located within a data center. So here is like distance between 100 meters to edge device to even 40 kilometers approximately. And here's like two main sources. It's cell tower data centers or on-prem data centers. And what is the three main types of architecture? The first one, that's obvious, it's pure edge. Yeah, so that's 100% edge architecture. These architectures do not include any off-premises resources. So all of them resources are on-premise. 100% edge architectures, like pure edge, are often used by organizations that do not send data to the cloud for security due to some privacy reasons. So it might be defense suppliers, pharmaceutical companies, or large organizations that have already invested a lot of money in on-premise computing infrastructure. Next one, that's what we discussed, thin edge, but thin edge plus cloud architecture. This architecture allows include cloud compute resources connected to one or more smaller edge compute resources. So thin edge architectures are often used to collect data from remote assets that are not part of existing plant network. And thick edge plus cloud architecture, these architectures always include on-prem data center plus compute resources, plus cloud compute resources. And optionally, it includes other edge compute resources. So here you can see like 3 different types of architecture, how we can use this edge. And from my point of view, they're going to be next step when we will move forward mostly to edge cloud. And some of the companies that have a lot of money, they can make pure edge, or the companies that need to do that. All of other companies probably will have kind of hybrid cloud edge. So here you can see like the integration advantages of cloud and edge. Providers of cloud, they understand all of this stuff, definitely. And that's example of AWS. So AWS already created a few products. I just mentioned, for instance, a few of them. That's AWS Outposts, AWS IoT Greengrass, and AWS Wavelengths. So all of them used by different reasons. However, that's all related to hybrid cloud edge solutions. And why do we actually need this hybrid cloud edge? Why don't we use just cloud first? Or why don't we use just pure edge? So the thing is, that's great, kind of sort some information, but store this information for a long period of time on the cloud. So intelligent edge computing, on this slide you can see the schema. So the first is like sensors from one unit. They can generate, as you can see on the slide, 30 gigabytes per month. Sometimes it's even more. If it's related to cameras, machine vision, it's gonna be even more. And then edge computing device, intelligent edge computing device, they analyze this data and send only crucial data, important data. It's like 150 megabytes per unit to the cloud. So the edge layer serves as a filter for your business critical data. Edge nodes can also process certain time sensitive data, but send to the cloud only the result of this processing. Like I already told you an example. For instance, IoT sensors installed on a compressed air system in an industrial facility, and they can constantly assess the system state. Imagine an IoT sensor spots an issue, then transfer information about this issue to the edge node installed in the same facility for immediate processing. Then the facility worker gets notified, like immediately, of this issue via the certain web portal to take immediate action. That's edge computing. But after the action is taken and the system work has resumed, the edge node can send to the cloud a brief report, not all of this information, just a brief report on when the issue happened and how quickly it was resolved. So that data analytics later conducts through analytics on how often the system falls during a certain period of time and how it affects business costs. So we can start machine learning in here, yes, and continuously improve our processes. Is everything so cool with edge computing? Of course it's not. There are a lot of challenges like data privacy and security. It's like the funny thing that it's duplicating strong sides of edge computing. The strong sides, it's also weaknesses, yes? So it's data privacy and security, training and adaptation of your staff or processes in the company. It's limited computational resources, but it's right now getting used to be better. Edge device monitoring, maintaining uptime and reliability in remote edge locations, and scalability, because scaling edge infrastructure to meet growing data and user demands, it's complicated. And speaking about your business, when edge computing should be chosen, we've already discussed the common benefits of edge. Yes, there are a lot of them. And here it's just the question, if you ask yourself about them, it's going to be easier to make a decision. Should you choose edge computing, or should you go with only with cloud, or should it be hybrid between edge and cloud? So when you see the necessity for real-time data analytics to ensure a better level of visibility within your organization, please choose edge computing. When the low latency, like, crucial for you, for your decision making, choose edge computing. When you want to ensure the highest level of business continuity and eliminate outages of your business critical application and devices, use edge computing. When your organization generates large volumes of data, and the distributed nature of data storage and processing that edge computing offers can be beneficial. You can also choose edge computing, and then it's critical for you to ensure the security of your business data locally and reduce the chance of fraudsters intervene in your edge IoT devices. That's kind of it for this part, and let's move to the trends. I don't have a lot of time, but let's go quickly through all of them. So the trend, not only for edge computing, but for all spheres of life for now, is security, and security importance and regulatory compliance. That's really important thing. And the trend is enhanced focus on edge security and data processing. It secures closer to data sources. Growing importance of regulatory compliances on the edge, ensuring data handling adheres to regional and industry-specific regulation or laws. So that's really important part, and that's trend for the next few years. Next point is synergy of 5G and edge computing. So 5G gives us massive bandwidth, and 5G brings to the market great features that make ultra-reliable, low-latency mobile wireless communication a thing. The advent of 5G will open up opportunities for a wider array of edge applications that can leverage its real-time and dependable attributes, so soon to be available in a private-to-operator network in your vicinity. Keep an eye out for further developments. And 5G network have the capacity to accommodate a significant number of devices, enabling the emergence of new categories of intelligent connected devices. And of course, it's AI, edge AI. Integration of AI and machine learning directly at the edge devices for real-time data processing and decision-making. That's going to be really beneficial. The data at the edge, whether structured or unstructured, is valuable. Many organizations have gaps in their data, and edge AI can fill these gaps by making data machine readable. So this is important for companies looking to improve their operations and gain better insights from edge data. The embedded community is getting ready for hardware and devices supporting AI and ML execution at the edge. This means massive hardware design changes and complexity, and an increased software stack complexity as well. Therefore, we will briefly speak about software stack. So for companies, C-level of companies, generative AI holds a lot of excitement, but it also brings some security issues, and edge AI can assist enterprises and consumer software companies in using this technology securely and privately, avoiding potential risks associated with public generative AI tools. Next point, I don't have enough time in here, like machine vision. It's going to be, from my point of view, key technology, especially in manufacturers. Yes, it's about also supply chain. It's about security. It's about a lot of stuff, even healthcare. Autonomous driving. So without edge, without AI, that's actually something impossible and unreal. So edge computing is used to process vast amount of data from various sensors as cameras, lidars, and radars to perceive and understand the surrounding environment and to make fast decisions quickly. And just a few slides left. So I want to briefly go through this topic as this might be crucial for the business. Scalability, security, technical gaps, there are and more other possible risks between like partnership challenges came in my mind. As technologies and solutions became more complex, companies are increasingly partnering with others to integrate their experience and provide complementary services to customers. So let's start from stack. Yeah, what is the best technology choice for edge computing? One of the most suitable technologies, it's subjective, but it's Rust, relatively new programming language that is taking over the market. Its most discussed advantages are speed and security. So in terms of edge computing, Rust provides a number of benefits such as easier code review, security audits, and more in comparison to Golang, C, or C++. Faster task execution compared to Node.js and Java, absent of runtime, making code written in Rust work faster as a Python, and the small memory footprint, which helps Rust work with not so powerful hardware, and that's vital for edge computing. So if you are considering edge computing, you should pay attention to Rust 100%. And how to choose your vendor? It's not about only software development. It's about buying some products, yes, ready solutions. So if you want to switch to edge or develop some IoT solutions, you should pay your attention on such things like solid track record of success cases, mature specialist on board, security department and compliances, because that's crucial, that's important, and technical support afterwards. It's not limited by this, as I mentioned before. It's much more like prices, long-term viability, solution accelerators, transparency, management, quality department, many other aspects that you should consider. But from my point of view, that's main of them. And that's actually pretty it from my side. I cannot say like edge computing is at a tipping point. It's time to unleash the potential of the edge. Yes, I will never say that cloud is dead, but I can say long live the era of the edge. Thank you.
That sounded powerful. Thank you so much, Dennis. Well, I was surprised about the statistics of adoption forecasted by the report you've provided. And I actually have a question dedicated to this topic. You mentioned the statistics, and we're hoping to get like 70% level of adoption among businesses. But what about the clients? The question sounds like this. Is it a common tendency among your clients to adopt edge computing?
Yeah, thanks for this question. That is not yet, I would say, but it depends on client, it depends on organization. Because as I mentioned during my slide deck, not all of the companies really need to have this edge computing. Yes, not all of them. But if you're speaking about manufacturers, yes. If you're speaking about latency and fast decision, 100% yes. But from Yalantis side, it's still mostly hybrid. It's not pure edge. That's edge plus cloud.
I see. So it's like in transition, right?
Yeah.
All right. Thank you so much. And just one more question for you. In what way does the transition to edge computing influence a company's revenue? And what is the typical return on investment in that case?
Yeah, thanks. That's a great question. So from revenue, I would say it's mostly about decreasing operational costs. However, speaking even about return of investments, about revenue, we should understand total cost of the ownership, yes, of this edge computing device. Because let's assume if you have a lot of places and you created a huge network of edge devices, yes, you need somehow to maintain, to support all of these devices, and it's also additional costs. So you should consider all of this stuff, and then carefully count should you take this decision to switch to the edge. But overall, mostly it's still positive ROI. I hope I answered.
Yes, yes. Thank you so much. Thank you so much for sharing your experience and giving such, let's say, an intro into the world of edge computing, which was really insightful. Thank you so much for this. Thank you for your report. Just wanted to give you a quick reminder, all of the audience and listening, those who are listening to us. Dennis Hukov is attending the IoT Tech Expo Europe and the Things Conference that will both happen in the next 2 weeks in Amsterdam. And if you're going there too, just let us know on LinkedIn. You actually had an opportunity to join Dan's LinkedIn profile on his presentation. And if you are going there, please let us know here in chat or on LinkedIn, or you can actually email us at hello@yalantis.com. So that we could meet there and just be happy to meet you there to network together and have an opportunity to chat about the edge computing and the overall IoT industry. Thank you so much, Dennis, again, for providing us with the information.